Hello everyone. So today I'm going to try once again to solve this problem. It is New Year's Eve and I'm quite excited because 2024 is coming up soon and I don't know what I'm going to do tonight, but well, I figured out I can just be doing some math because math is fun. So anyway, find the integral. Okay, I forgot to put this. Find the integral of x squared plus 1 over x squared plus x dx. So this one is a quite complicated subject. If you think that you're going to be using substitution to solve this, well, you might get into a lot of issues when you try to solve this. So the best approach is also not to use partial differentiation, derivative, integration by parts, integration by parts, because this one is gonna be very challenging. Maybe if you want to do that, you'll end up using x squared plus 1 times 1 over x squared plus x, and then if you try to use integration by parts, it's going to be very long. So what we can do here, we're going to be using fraction decomposition. So what that means is that I'm going to take this fraction, this whole thing, I'm going to take this whole thing and I'm going to break it down into small chunks, into smaller pieces, which eventually are going to help me solve the problem. But first, before I do that, I need to simplify this. So one of the best way to simplify this is through division. So I'm going to take this whole equation and divide it on the other side. So here I go. I have x squared plus 1 divided by x squared plus x. So I'm going to divide the first one. I'm going to look at the first component of this and the first component of this. So how many times can this one enter inside of this? This is 1. So what I'm going to end up doing is I'm going to put my 1 on top. 1 multiplied by x squared. Of course, because I'm subtracting, I need to put the sign out. Plus 1 times x, give me x. So this one will cancel because x squared minus x squared, because the sign will change. So the sign here will become negative. So this plus will become negative. So I end up with x squared minus x squared, which give me 0. So down here, I have 0. And then I'm left with negative x, because the sign multiplies here, remember? So the sign is distributed inside. So I'm going to end up with negative x. And I bring this one down here, which is plus 1. So I don't know any way I can try to put x squared inside here. So there's no way I can put x squared inside of negative x. So what I'm going to end up doing is that this is going to be my remainder. So I have 1. Now I have 1 plus negative x plus 1 over x squared plus x. Perfect. Now with this, I can come here and put it back. Sorry, I love errors. Really love errors. Can put it back here. So I end up having to find the integral now of 1 plus negative x plus 1 over x squared plus x. So now, I simplify this into something that I can work on to decompose. So next step is to decompose this, I need to make sure that I follow a set of rules. So the rules are usually a over x plus b over x plus something or whatever, something like that. So a, b, c, and the rules are very long, but easily understandable. So what I'm going to do here, I'm going to simplify the denominator. When I look at the denominator, what I notice is that we have x on both sides. So we have x squared and x. What I'm going to do next is I'm going to take x, decompose. I'm going to factor it out, factor out the x and be left with a different set of equation. So of course, never forget to put dx. I end up with finding now the integral of 1 plus negative x plus 1 over x, because I factor my x, I end up with x plus 1. Perfect. So now with this, I'm going to use that rule that I was showing you earlier today. So this whole thing here is can be actually decomposed. So my next step is doing this. So I'm going to go ahead, find the integral of 1 plus end up of 1 plus, so negative, okay, actually I'm doing it wrong here, sorry. I'm going to decompose this first. I'm going to decompose this one first and then bring back to find the integral. So the way I'm going to decompose it is I'm going to do it on the side. I'm going to do it on this side. This arrow is too long. I'm going to do it on the side. So I end up with negative x plus 1 over, as you can see here, I have x and I have x plus 1. So I'm going to keep this whole thing but decompose it later on with a, just as I was showing. A is going to be a over x, which is my first factor here, and then plus b, which is going to have x plus 1 here, which is my second factor. It looks strange, but you see how it works. So I end up with x plus 1 is equal to a, and I need to find a and b. That's why I'm doing this, because when you multiply them, when you add them together, you're going to end up finding this as a whole. So I need to find what are those values of a and b, which are going to help me solve the equation, because just as I said, we are decomposing the entire function. So a over x plus b over x plus 1. Now we have another thing to do here. I want to get rid of this denominator on this side, because if I try to work on both sides with that, it's going to be a mess. So what I'm going to do is I'm going to multiply both sides by the denominator to get rid of the denominator on this side and on the other side. So I end up, what do I end up having is negative x plus 1, sorry, I'm going to do it step by step, over x plus 1 multiplied by x plus 1. Because if I do this now, these ones will cancel. So I'm going to end up having negative x plus 1. Since I multiply on this side, I'm going to also multiply on the other side. So I end up having a over x plus b over x plus 1. The whole thing multiplied by x times x plus 1. When I distribute this on both sides, you will notice that when I multiply x times x plus 1 with b over x plus 1, this is going to cancel, right? So I'm going to end up having b just multiplying with x. And on the other side, I'm going to end up having x being cancelled. Sorry. I'm going to use another color because it can be confusing. I'm going to end up with x being cancelled here for a, and then only remaining a times x plus 1. So I'm going to put it down here. So I end up with a x plus, oh, this is actually a horrible color. I'm going to change that immediately. That actually is a very ugly color. I'm going to go back to white. So a x plus 1 plus b x, right? So I'm going to use the second page. I'm going to go ahead, simplify this, distribute this, my apologies. So I end up with a times x, which gives me ax, plus a, which is a times 1, so plus a, plus bx. Now, what I can do is I have ax and bx. Both a and x have the same degree of x, so there's x to the power of 1. So I can combine them together and say, you know what, I'm going to end up having a plus b times x, because if I do a times x and b times x, I end up with ax and bx. And on the other side, I end up with a. And if I look back, this whole thing was equal to negative x plus 1. Actually, I'm going to go on the other page. So I end up with negative x plus 1 is equal to a plus b x plus a. Remember, we're trying to solve for a and we're trying to solve for b. So now I look back into this side of the equation. I see that 1 is a constant here. And a on this side is also a constant. It's staying alone here. So that means that the value of a is actually 1. Amazing. So I solve for a. So a is equal to 1. And on the other side, negative x, so negative x is equal to a plus bx, because this one has x, this one has x, and this one did not. So since I found the value of a, I can substitute a here and try to solve for b. So negative x is the same as negative 1 times x, right? And then I have here, so it's the same as 1x. And I can get rid of the x on both sides so that I can simplify it and find b. So I end up with negative 1 is equal to, now I know the value of a, so a is 1 plus b. And I'm going to try to solve for b. So I bring 1 on the other side. So I subtract 1 on both sides. So negative 1 minus 1 is equal to 1 plus b minus 1. These ones we cancel. So I end up with negative 2. Negative 2 is equal to b. Perfect. So this is where I stand now. Remember, we were looking for a and b. And if I go back to the page earlier, I know that a was a over x, and then now that it's 1, I can just substitute 1 here, and I now know that b is equal to negative 2. So this is going to be equal to negative 2 over x plus 1. So to recap, we first divided the equation. I first divided my equation here. And after dividing it, I took the factor down here. So x and x plus 1. And then I decomposed the function to find the value of a and b. So now that I have the value of a and b, so this whole thing is equal to 1 over x plus negative 2 over x plus 1. So now I can find the integral of course, of this whole thing. I'm going to go ahead. So I have the integral of now 1 plus, a was 1, so 1 over x, plus, of course, entre parentheses, negative 2 over x plus 1 dx. So now, it's easy. I can just distribute to find the integral. It's just easy now, I think. So I can just be like, okay, I'm going to take the integral step by step. So I'm going to take the integral of 1 plus the integral of 1 over x, because we just add up together, plus the integral of negative 2 over x plus 1 dx for the whole thing. I'm just going to put it this way. I don't know if, no, that's actually wrong. So dx, yeah, the x is already there. Actually, this is not working. So 1 dx plus, and I erase this one so that it looks proper, dx plus negative 2, yes, over x plus 1 dx. The integral of 1, which is a constant, is just x when I'm going backwards. So if I had 2x, and I take the derivative of this one, that would give me dx. This would give me 2. So if I go backward, it's going to give me 2x. And that's exactly the same logic here. The integral of 1 is going to be x. So I end up with x. And the integral of 1 over d over x, if I look back into my formula sheet, which I don't have right now, but it's somewhere, is natural log of the absolute value of x. And the same thing goes again here, where I can just say, you know what, I'm just going to take the negative 2 out and find the integral of 1 over x plus 1. Because if I multiply negative 2 here, I end up with negative 2 over x plus 1. And this, I'm going to find the integral. So I know that I'm going to have to use the, how do you call this? The quotient rule, I think so. No, I'm just going to use the same rule that I used to find the integral of 1 over x, which is basically the natural log of whatever is inside of whatever is the denominator, I mean the absolute value of the denominator, times the derivative of the denominator. So if I take the derivative of x plus 1, so that ends up being 1. So times 1, this is my new form, my answer. So to put everything back to normal, and my answer will be x plus natural log of the absolute value of x minus 2, these 2 here, times natural log of the absolute value of x plus 1. So this is my answer, but please do not forget the c, because it's an indefinite integral. So if you forget about that, I know my professor used to deduct mark for that. So please do not forget that c, because it's very important. Thank you so much for watching, and I hope this helps. And you know what? Happy New Year for everybody. Bye.